Okay, welcome America, welcome Taylor Swift. We're trying to get Taylor Swift to come to DC because we looked at her tour and she does not have a DC location. So we are going to, we're gonna hound her until she adds a DC location. So today we are going to go over ways to prove triangles congruent. And we're gonna start with what's called a two-column proof. It's the first one that we've seen, and we'll do more of these, but it's the beginning of what we call a proof. We used to do lots of proofs in geometry, and now we kind of just touch on them and move on, and there are classes in college. There's a class that I took in college called proofs. It was just all proofs. So this is an introduction. So we have given statements. I know it's a little hard to see online. So we're given that AB is congruent to DC. Let's look at the diagram. We're going to take this information and put it on our diagram. AB is congruent to DC. So here's AB, and here's DC. So I'm going to put a little mark that they're the same. Put it on my diagram. Next piece of information that's given is AC is congruent to DB. Where is that? AC is over here. DB is over here. Put that on, and I put 2 marks because I wanted to show that these two are congruent and those two are congruent. So I just used 2 marks for the second side. So now that I've put the given information on my diagram, the diagram shows a 2-column proof. Mark up your triangle using the sketching tool. Okay, so we are going to order, are we going to order the reasons? Yeah, all right. So the way we write a 2-column proof is we have the statements, we state what's happening here and what's true. And then we say the reason that we know that on this side. And then we start with the given information, and at the end, we have the last one should be the one that we want to prove. This problem is asking us to prove that triangle ABC is congruent to triangle DCB. And the way we're going to do that is we're going to step by step show we know this for this reason, we know this for this reason, we know the triangles are congruent. Why do we know the triangles are congruent? And it should be by one of the ways to prove triangles congruent that's on your summary. So, and I will attach the summary on this video. Hopefully I remember to do that. So, why do we know that AB is congruent to DC and AC is congruent to DB? This information. We know that because it's given. So the reason is given. I can't drag given to the top when I'm using the annotation tool, so I'm just going to write given here. But go ahead and drag your given to the top. Next piece of information. Now, remember how we were talking about in the last problem? When the 2 triangles share a side, we can assume that that side is the same length in both of those triangles. So I'm going to put 3 marks on that one because I know if I were to separate these 2 triangles and draw them separately, like the top one here and the bottom one here, okay, oops, and just put all the marks again. It would look like that, okay? We don't need to go through all that. That's what I'm doing when I put these 3 marks here, because that side is definitely the same length in both of those triangles. Well, now let's look at it. How do we know that BC is congruent to CB? That's called the reflexive property, and that's back from Algebra 1. So I'm going to write reflexive property. I'm just going to write reflexive. Okay, so drag drag the reflexive property to the second one. And now we should have enough information to prove that 2 triangles are congruent, and we need to say why. So if we look at the 2 triangles, we know that all 3 sides, all 3 sets of corresponding sides are congruent. And this is called side, side, side. So take a look at your summary. Take a look at the side, side, side example. And doesn't this match it? All 3 sides. This is enough information to prove those 2 triangles congruent. No matter what we do, if we've got 2 triangles and we have 3 sets of corresponding sides that are congruent, there's no way we can make these triangles not congruent. So that guarantees the 2 triangles are congruent, which is why it's on your summary for a way to prove triangles congruent. So we know the 2 triangles are congruent. Why? By side, side, side. And you just wrote your first proof. That's it. That's all there is to it. We go from the given information to what we need to prove. Any questions? All right, let's see if we can get one more example in before I have to finish. Oh, this is a good one. All right, so whenever we do a match, we're going to go ahead and put these ways at the top, and it doesn't really matter what order you put them in. I'm just finding them and dragging them to the top, and now we're going to match them. Well, side, 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 usually pretty easy to identify because it's got all 3 sides. So this is side, side, side. Okay, SAS is when we have 2 angles and 2 sides and an angle in between them. So where do we have that? Where do we have 2 sides and an angle in between? Take a look at this one. See how we have 2 sides and the angle in between? This is SAS. Side, angle, side. Okay, and we just discussed the difference between angle, angle, side, and angle, side, angle. In angle, angle, side, the side is on the outside of the 2 angles. In angle, side, angle, the side is in between the 2 angles. So let's see what we can do here. We've got this one. See how the side is on the outside of the 2 angles? That's going to be angle, angle, side. Here, this is on the outside as well. This looks like SAS to me. Wait, no, sorry. That's not SAS. We've got a side in between 2 angles. So this is angle, side, angle. And the last one, again, we've got a side in between 2 angles. So that is angle, side, angle. Any questions? All right.